Can you hear us? Yes, okay. So I would like to greet everybody, both in person here in the FAO headquarters and online, all the audience, especially those who are persistent enough to join us again after the morning session of this symposium, the second symposium, International Symposium on Biosecurity in Beekeeping, co-organized by FAO, IZSLT, the Sperimentale Zooprofilattico Institute here in Rome, the World Organization of Animal Health, and Apimondia. This event is organized on occasion of the World Bee Day, which is due this week, and we would like to share some good practices and innovative initiatives on biosecurity and bee health, especially on honeybee health. But this event is also special for us because this is the anniversary of the nominations of the Apiculture Lab within the Istituto Zooprofilattico Sperimentale here in Rome. In 2021, the laboratory was nominated as a WOAH collaborating center responsible for good beekeeping management practices and biosecurity measures in apiculture. And 1 year before, in 2020, it was awarded FAO Reference Center title in apiculture, health, and biosecurity. And I would like to introduce ourselves, moderators. My name is Andrea Györfi, and I'm starting with the moderation, and then I will give the floor to my colleague, Veronica Manara from the Istituto Zooprofilattico Sperimentale. I would like to also call your attention to some household rules which will apply here. So the meeting is recorded. Please notice, and if you have any concerns about that, please let us know. The second thing is what I would like to announce is the agenda. So first we will have welcome remarks from our guest speakers, both online and here in person. Then we will have 5 talks on biosecurity in beekeeping, and then we will have a maximum 40 minutes long question and answer session at the end. So for the question and answers, please don't forget to use the question and answers box within Zoom platform. And otherwise, you can use the chat box for introducing yourself and your country affiliation. And what would be important, as you might already got used to it during the COVID times, that the time frame is quite rigid in case of webinars. So please pay attention to the time limits, but we have both speakers, please, and both in case of a question and answers session. So, and I would like to introduce first now our speakers who will bring you the opening remarks on behalf of the organizers. I would like to introduce Junxia, who is a senior animal health officer working for the Joint Center for Zoonotic Diseases and AMR at FAO headquarters here in Rome. She's coordinating AMR and endemic zoonotic diseases across the organization. The second opening remark will be delivered by our colleague at the World Organization for Animal Health, Fracois, Diaz, who will join us online. He works for the WOAH as a scientific coordinator for wildlife and bees in the Department of Preparedness and Resilience. And Mr. Jeff Pettis will close the row of speakers for the opening remarks. He's an entomologist specialized in honeybee health, and he was have been working for USDA for more than 20 years. And now currently he is the president of Apimondia. But maybe most importantly, he is also a beekeeper for over 40 years. So I would like to ask Junxia to give the first talk on the occasion of opening this session. Thank you very much, Anja. Dear experts, participants, good morning, good afternoon. And on behalf of FAO, I'd like to welcome all the speakers, panelists, and participants to this webinar in person or virtually. I appreciate your interest and effort to protect the beekeeping and bee health. In 2018, UN General Assembly declared 20 May as World Bee Day. 2 days later, we will celebrate the 6th World Bee Day. So I want to open this webinar by highlighting the importance of bees in our life. As pollinators, the bees contribute to our food security. Without the ecosystem service of bees and other pollinators, about 70% of the world's crops, including fruits and seeds, will be lost. We all love honeybee products, such as the honey, the propolis, and bee wax, and the royal jelly. So those are very helpful to improve our nutrition and also very good for our health. Their pollination is also contribute to preserving biodiversity and forest regeneration, which helps to mitigate climate change. Beekeeping is such a successful source of income in rural areas, benefiting communities like livelihood in and around forestry areas. So with that, you can imagine how hardworking the bees are to achieve sustainable development goals. To keep all those valuable bees, we should sustainably protect their health. We should think about to reduce the use of chemicals around bees, including antimicrobials, consider alternative measures such as good beekeeping practices and biosecurity measures. Over the last year, we have already developed the guidelines to promote good beekeeping practices, biosecurity, and responsible use of antimicrobials, working closely with IZSLT, our reference center for animal health, food security, agriculture health, and biosecurity. Also with IZSLT, Apimondia, and also WOAH, and other international experts, we have developed the Progressive Management Pathway for AMR and beekeeping. This is a stepwise approach to guide the national beekeeping system towards the sustainable plan. We are very pleased to organize this webinar together with Apimondia, WOAH, and our reference center, IZSLT. I'm looking forward to listening to your thoughts and insights about the practical yet powerful biosecurity measures to protect the health of bees. Thank you. Thank you very much, Junxia. I would like to call Francois Diaz to give the next presentation occasion of on behalf of WOAH.
Yes, thank you. Thank you for the introduction. So dear participants, dear experts, dear panelists, good morning, good afternoon. Antimicrobials, including antibiotics and antiparasitics, play a crucial role in preventing and treating infection and disease in humans, animals, and plants. Their overuse and misuse in people, animals, and plants is the main driver of antimicrobial resistance. And antimicrobial resistance threatens global public health, food safety, food security, and economic prosperity, as well as planetary biodiversity and ecosystem. Therefore, this international symposium on beekeeping biosecurity, which will highlight in particular alternative to the use of antimicrobials, it's a good initiative to present best practices for beekeepers in the framework of the responsible and prudent use of antimicrobials. So, welcome to this symposium. Thank you for inviting me, and I wish you a successful symposium. Thank you.
Thank you. It's a pleasure to be with you, Apimondia, and again, our thanks to the Istituto Zooprofilattico, IZSLT, also to FAO for hosting. And I'm delighted to see my old friend Francois Diaz, but you're stuck in the clouds somewhere, Francois. I don't know. It looks like, yeah, but it's and I still use the OIE, but I know it's OAH. So, yes, antimicrobial resistance is one of the issues facing beekeeping. And we know that beekeepers around the globe have in the past relied too heavily on antibiotics, and it's a use that we need to move away from. The bees themselves can adapt, and the bees themselves have good hygienic behaviors and things that we need to rely more on, not so much a quick fix with antibiotics. But I'm looking forward to hearing from many of the speakers. We have some experts here to present various aspects of the biosecurity issues facing bees and beekeeping. And so we're just proud as Apimondia to be a part of it and to be here together on this webinar.
Thank you, Dr. Pettis, for this comprehensive introduction. And I would like to ask everybody to turn on his or her cameras for the group photo online. Yes, sir. Thank you. So we are moving on to the talks on professional issues, and I'm giving the floor to my colleague Veronica Manara. She will serve as your moderator in the upcoming 1.5 hours. Thank you.
Thank you very much, Andrea, for the introduction. I conclude the opening remarks by thanking the speakers for their heartfelt words and for paving the path towards a fruitful discussion. We will now begin the symposium on biosecurity in beekeeping. The first presentation will be given by Dr. Jieun Kim from the Food and Agriculture Organization of the United Nations. I will introduce Jieun Kim first. Mrs. Jieun Kim is an animal health officer at FAO headquarters, where her work is mainly focused on supporting countries in implementing the national action plans on AMR in the food and agriculture sector and protecting the health of bees across the regions. So I kindly ask Dr. Jieun Kim to start her presentation.
Thank you so much, Veronica, for the introduction. I will share my screen. Yes, so I prepared a presentation to introduce FAO's Progressive Management Pathway for antimicrobial resistance in agriculture, supporting countries to adopt the good practice and biosecurity at the policy level. First, I want to introduce the FAO's action plan on AMR 2021 to 2025 to give a brief overview of 5 objectives and we call it area. We have this action plan. It is the document that we have put all the plans for 5 years to support food and agriculture sectors and also its dependent livelihood and economies to make this more resilient to impact of AMR. So we have 5 objectives here. First objective is increasing stakeholder awareness and engagement. And the second is strengthening surveillance and research. And the third one is enabling good practice to prevent infection and control. And the fourth one is promoting responsible use of antimicrobials. And the fifth one is strengthening governance and allocating resources. So the food and agriculture sector, I want to clarify which sectors are included. Of course, animal health sectors are included, and also crop production, health, environment, and aquaculture. So as we see here, bee is a very important animal sector. We should work together to support this sector as well. What do we know about the beekeeping now? According to FAO 2022, the number of beehives has increased in past 10 years. While this is very positive data, also it's concerning more disease concern is raising because it may drive more use of veterinary medicine, including antimicrobial, to prevent or treat bee disease. And therefore, it's very important promoting good practice and biosecurity measures from FAO side. I want to see also bee health issue under the One Health concept. As you may have heard about One Health, this is the One Health approach, like where human, animal, and plant and environmental sectors are working together. It is starting from the recognition of the fact that the sectors are closely linked and interdependent. So if you see bee health, bee as an animal, it's very important to protect bee. But the reason is for their pollination activity, they are closely interacting environment and plant health sector. But also it gives a human a lot of nutrition source, and also for human the livelihood is very important for rural communities, for beekeepers especially. So it's very important to protect bee health based on good beekeeping practice and adopting biosecurity measures to prevent any risk of introduction of any honeybee disease. But protecting bee health is beyond just protecting bee health. It's also protecting human health and environmental health under the umbrella of One Health concept. So for this, FAO developed a progressive approach, which is a very long-standing approach. So I want to give a little bit of introduction how we developed this approach. This is a stepwise approach for a country to reach a specific goal, mostly eliminating the disease. So you may heard about some animal disease such as foot and mouth disease, animal African trypanosomiasis, and also brucellosis. So we want to control this disease and then eliminate at the end and eradicate even. So that's why we have a progressive control pathway for this reason. As you see in the right side of your monitor, there are 5 steps that we take to eradicate the disease. So first, we start from assessment, and the second, reduce the disease, and then eliminate the disease, and the first step is eradicate disease. And the last one is a certificating country for maintaining this eradication status. So this is our approach for this animal disease. But we have also some antimicrobial resistance issue. This is called threat, it's not a disease. So this is also natural phenomenon as well, as you see. This is accelerated by overusing and misusing of antimicrobials. So we cannot eradicate this phenomenon, but we can manage sustainability of the issue. So as you see, we have a stepwise approach under 5 areas, but you may see we have currently 4 areas. This is because the responsible use of antimicrobial and practice are incorporated under the practice. But the important thing is under each area, we want to take the stepwise approach to guide countries to reach to the ideal stage, which is maintaining sustainable management of antimicrobial resistance. So we adopted this progressive management pathway structure for beekeeping, aiming the sustainable beekeeping. Our tool is structured. We start from the stage 1, identifying risk, and then assess the situation. It could be through a survey or inventories, developing the inventory. And then we're stepping up to stage 2. We suggest countries to have small-scale initiatives at local level or community level. And the stage 3 is sustainable beekeeping at the national level. So it's the difference between stage 2 and stage 3 is you take the nationwide approach, so at the policy level. And then stepping up to stage 4, you maintain the sustainable beekeeping and then building resilience. I took some examples. So under the awareness area, we have the topic, among other many topics. We have a very important one, training on AMR and sustainable beekeeping for beekeepers, which is very, very important in beekeeping. And the first step is always starting from assessing the situation and knowing your situation. So we ask country, do you have any inventory of existing training courses? And then if you have, second step is if you have small scale initiative, like such as setting up small scale training course, possibly in collaboration with local beekeepers association and government institution. And the next step is nationwide approach. So if a country has already set up nationwide training, possibly in collaboration with national beekeepers associations and in government institution. The last ideal stage is sustaining this good nationwide approach, plus also engaging in the policy level. So depending on country situation, of course, maybe certificate the mandatory training for beekeepers and mandatory training for beekeepers or other comparable approach country can take to sustain this nationwide approach. I took another example from governance area, which is the topic is monitoring honeybee mortality. So we always take the same approach from first assessing the situation. So assess the existing system to monitor honeybee mortality. If you know already the situation, the second step is taking small scale initiative. So if a country has already developed a procedure at local or regional level, and third one is of course involving the policy and legislation. So develop national legislation to investigate the honeybee mortality. And the fourth one is review and revise national legislation on a regular basis. Depending on the country's situation, it could be every 5 years. So these are some examples. And the benefit is we have 27 topics to discuss among the national stakeholders on beekeeping, and also other one has stakeholders under 5 areas. So you can approach the beekeeping with a systematic approach, and also peer assessment in helps environment to achieve the sustainable beekeeping at the policy level. So you can really create the environment in country, so you can adopt good practice and also biosecurity measures. And then also assessment workshop gathers all the beekeeping stakeholders, and other one has stakeholders including plant health, for example, and also environment. Yeah. So this is the dashboard that at the completion of the tour, you can check the numbers quantitatively, and then you can see the status. And over the reassessment, you can see the progress 2 to 3 years, depending on country context. And after completion of the tool, over conclusion and over action points should be agreed. So you can step up to our next stage as a country. So you can really use the PMP approach to monitor the progress made for the implementation of the sustainable beekeeping. And also you can identify actions to address the gaps and challenges for the implementation. And then you can prioritize the action in the resource limited setting. And then if you don't have enough resource for other actions, you can utilize this identified action to mobilize more resources as a project, a proposal, for example. I want to give a little bit of also a background, the overview of other works we are doing as a FAO with our partners, with Apimondia and also IZSLT, our reference center, and Argentina State University. We disseminate global survey to understand the beekeepers' knowledge and awareness, and also practice on AMR, a new good beekeeping practice. So this is already disseminated in 2029, and also 2022 we disseminated, and the report will be also available very soon. And also we have developed this guideline that also Dr. Junxia mentioned. It's very useful to understand the basic good beekeeping practice and biosecurity measures in beekeeping. So I put the slide here. And I really acknowledge our partners here, IZSLT, WOAH, and Apimondia, for this long collaboration together, and also the experts review and revision provided by all the international experts on 28 November 2022 for the Progressive Management Pathway tool in beekeeping. And also, I really appreciate UNLP, Universidad Nacional de La Plata, Argentina. Currently, we are collaborating to possibly pilot our PMP workshop in Argentina soon. So I will stop here. Thank you so much.
I thank you kindly, Dr. Jieun Kim, for her introduction of the Progressive Management Pathway and for the very instructive presentation. And I now move on to the second presentation of the day, which will be provided by Dr. Adriana Alippi from the National University of La Plata. Dr. Adriana Alippi is a senior researcher of the National University of La Plata. Within honeybee pathology, her lines of research include the study of biodiversity of strains of Bacillus larvae and the analysis of active metabolites produced by strains of Bacillus and related genera against American foulbrood. She was the expert in charge of the OIE reference laboratory for the American foulbrood in Argentina. And I will now give the floor to Dr. Alippi, which will please introduce the second presentation. Thank you for inviting me to this presentation. Well, I am glad to be here sharing with you. Please help me, or I must share the screen. Okay. I will be talking about the possibility of the substantial control of honeybee bacterial diseases using bacteriophages. Well, within the honeybee diseases, the most important bacterial diseases that affect the larval bee growth are American foulbrood and European foulbrood. This is a picture of a brood chamber affected by American foulbrood. You can see the cappings are removed of the, and you have a special mosaic pattern with, which is not the same as a healthy brood. You can observe sunken cappings with their oil appearance. Next one. Next one. Well, if you introduce a small seed inside one of these cells, you can spread out a mass, a very sticky mass of about 2.5 centimeters long, which is a typical clinical sign of disease. And well, at the final stages of the disease, the pupa, the larval pupa, transforms to a scale which is firmly adhered to the end of the cells, and in some cases you can see the pupal tongue protruding to the upper side of the cell. These are typical symptoms of this disease. The next one. The second major bacterial disease is European foulbrood, which presents a similar pattern, but as you can see, the larvae are located in open cells with strange positions, and also the pattern is like a scatter, different. It's not it seems to be a problem of the queen, the failure of putting the eggs or things like that. But no, this is the typical symptomatology of the disease. Some beekeepers can mix up both symptoms. So if it's necessary, it's recommendable to send the sample to a laboratory to be precise if you are in front of European foulbrood or American foulbrood, because, well, the management is not exactly the same. The next one. Well, this is an approach of the disease larvae that also in the later stages transform in a scale, as you can see in the down one in the middle. But always the scale, it's like a glue, but not spreading out. And also it's easy to remove from the cells. In contrast with American firewood that, well, it's pretty hard to remove the scales from the cells. Next one. Well, this is the causative agent, Penisococcus plutonius, the cause of European firewood, which is a gram-positive, non-spore-forming bacterium. Next one. So it's not so complicated to manage this. In contrast, American firewood is also caused by a gram-positive bacterium, but in this particular case, is an spore forming belonging of the Bacillus genus. Previously, it was called Bacillus, but the reclassification of the genus differentiated different species. Now, Bacillus larvae is the current scientific name. These spores are very resistant, highly resistant to desiccation, to UV light, to heat. Well, they survive for years in the colonies. And also, more than it's possible that this bacteria can survive in scales affected by the disease for more than 35 years. We recover from the lab from symptoms of scales of American firewood kept in the fridge after 30 years with complete viability. Next one. Well, there are several means to control this disease. The first one is to burning all the infected hives to destroy the spores and try to eradicate the disease from that area. But, well, it is possible to save the wooden material, not the wood, but the wooden material like gamma irradiation or by immersion in paraffin oil. This technique is used in New Zealand, but the problem is that paraffin melts at 150 degrees and also is toxic and could be toxic for the beekeepers, and it's complicated to manage it. Other possibility is the use of antibiotics to control the disease, mainly in American countries, particularly in Canada and the USA. But you can have different applications. You can apply it by paper pack or a dust or over the wood chamber, and also as a packing for the liberation, a slow liberation. The most common antibiotics used are oxytetracycline and tetracycline since 1960 in America. But the problem is not only honey contamination with residues of these antibiotics, but also the appearance of resistant strains of Bacillus larvae to oxytetracycline and tetracycline. And other alternatives are tylosin and trimicocin, other antibiotics, but the problem in this case is the residuality in honey. In the case of Argentina, we use antibiotics when the disease appeared in 1989 during many years, but as Argentina is one of the honey exporting countries, the problem is that the residues can be detected and all the samples were refused, particularly in the European Union, where zero antibiotics is allowed for honey. So since 2019, antibiotics were forbidden in Argentina to control the disease. Next. Well, like larvae resistant strains to tetracycline have been found in USA, Canada, and also in some Argentinian samples. And next one. we discovered that the tetracycline resistance in this particular bacterium is mediated by a small plasmids that replicate by the rolling circle mechanism, and those plasmids contain the determinant PET-E, which is a determinant of tetracycline resistance. We fully sequenced the 3 plasmids isolated from USA, commercial honeys from USA. And next one, we found almost 100% of homology without other plasmids of other bacterial species, not only Bacillus larvae, the 31, 395, 373, and 374 is from our lab, and the other PMA 67 from from USA in a publication of Murray and co-workers. But also exactly a very high similarity with other bacillus, another genera of bacteria that possesses exactly the same plasmids, and also very similar plasmids that have been reported in other species. So the antibiotic resistance is widespread within bacteria, particularly on gram-positive. Next one. Before that, I would like to explain that we also in our lab try to determine if the resistance could be horizontally transferred, and we successfully transfer the resistance, the plasmid modifying the resistance from one resistant strain to one susceptible strain of Bacillus larvae. When we try to cure, it's a possible technique using heat and different drugs, and we eliminate the plasmid from the donor, and the acceptor, the strains recover the susceptibility to the antibiotic. It was the first experiment with a conjugation, and also we transmit the resistance by electroporation. And also we tried to do the same experiment with another bacillus, another spore-forming species, which is Bacillus subtilis, which is common in habitat of the hive from honey, and so in the apiary, it could be, there are lots of bacillus and spore-forming, which are commensals or not harmful for honeybees, sorry. But we were able to transfer by conjugation the resistant plasmid to the Bacillus subtilis strain. So it's important that not only for residues in honey, but also for the spreading of resistance horizontally between bacteria from the same ecological niche, like a comb or an apiary, within the apiary. So, next one. We try to find alternative possibilities to control the disease that will friendly with the environment. So one possibility is the use of bacteriophages to control the disease. They seem to be attractive natural alternatives. These are a picture of a bacteriophage and set different types. Next one. But what are bacteriophages? Bacteriophages are viruses that only infect and replicate in bacteria and are highly specific for their host. They take advantage of the bacteria biosynthetic mechanism and is directing it toward the synthesis of more phages that would be able to produce the bacterial releases, and in that situation, a new phage released to the environment. The extreme specificity of the phage is observed, and their ability to bind an infection only to the target bacteria, but are highly specific. If it is a bacteriophage active against Bacillus larvae, it only affects Bacillus larvae. And other times only affects particularly strains of the bacteria, like maybe one or two genotypes. And leaving other bacteria and eukaryotic and have also bacteriophages showing no toxicity to plants, animals, or humans. And also, they are not toxic against honeybees. Next one.
So I can yes, Dr. Alippi to lead towards the conclusion.
Oh, sorry.
Yes.
Well, this is a picture about a isogenic cycle in regarding a FASH, and then they can possess the capacity to transform in a lytic cycle, and then is infective. Next one. Well, there are several advantages to use bacteriophages, which are bactericidal agents, a high specificity, a narrower potential for reducing resistance. And of course, as they are not antibiotics, it's not possible to have a cross resistance with antibiotics. Next one. Also natural products and act on a biofilm, and they have a relatively low cost, and the formulation and application is versatile. But which are the main disadvantages? The narrow host range only affects particular strains of the pathogen. So this can be solved by the preparation of a cocktail of different phages. And another disadvantage is the unfamiliarity with people to bacteriophages, to the general public, because these are viruses. So the public said, no, could be COVID or something worse, so better to not use it. But this could be easily solved by giving information to the general public. And also another disadvantage is that the phage should be sequenced and characterized before being used. Next one. Well, these are some examples of phages affecting Bacillus larvae. This belongs to the Myopuridae class. So next one. This belongs to the Cyphopyrus family, which has been isolated from different Bacillus larvae. Next one. Well, this is a form to isolate and purify the phage from bacterial disease. I mean, from scales or from viscous material. And then you can try a spot test to verify if the bacteriophage that you isolated is lytic. Next one. We must prepare a high titer stocks of phage. We repeat the purification and obtain a titer of the phage. Next one. And well, then you must count the lysis flux to know the concentration of each phage preparation. Next one. Well, this is, we isolated 8 phages in our lab in comparison with one phage, PBL1 from USA, some are from Argentina, one from Sweden, 2 more from USA, and 1 from Italy. And we tested 55 different P. strains in the lab, and all have different sensitivity. Each phage have different sensitivity, different action to the bacteria, because some strains are sensitive to all the phages, and others are resistant or are resistant to 2 or 3 phages, and the rest are. So it's recommendable to use a cocktail of phages instead of just one. And as a conclusion to end it, I would like to show you a paper published by Dr. Scott Brady and co-workers trying a specific preparation of phage for the control of American foulbrood. They isolated the phage, purified it, and then prepare a suspension in a syrup with glucose, and it's applied in a feeder to the colonies. But then they made 2 experiments. The first one you can see on the left of the slide, that they tried to know if the phage preparation was toxic against larvae.
And they prepare 3 different concentrations, and one a very high concentration in relation to a control with saccharose and water. And they did not find any statistical differences between the larval mortality between treatments, so are not harmless for honeybee larvae. And in the second experiment, they tried the bacteriophage preparation against American foulwood colonies, showing disease signs. In the first experiment named R, American foul, they inoculate the phage with the bacteria, and they determined that after four weeks, they use a scale, an arbitrary scale, where 0 is no symptoms and 3 are almost died, the bull are many larvae dead. So the phage treatment is near 0, and the mock treatment, the control, it's in between 2 and 2.5. And in the second one, you can see that this was after the clinical signs were observed. So 2 weeks post-attachment treatment on disease colonies, the infection disappeared. So the phages can be used as prevention or as a curative treatment. Next one. Okay, thank you so much.
Thank you, and thank Dr. Alippi for her comprehensive presentation. We will now dive into the third presentation of the day, given by Dr. Fani Hatijna. She's a biologist with a PhD on pollination. She has published over 70 scientific articles and coordinated more than 16 research projects. She is the director of the Institute of Animal Science in the Department of Agriculture and the president of the Scientific Commission of Apimondia for Bee Health. So please, Fani, the floor is yours.
Hello. Something's happening here. For some reason, I can't. But okay. Can I share it myself? Can I share it myself? Because that's why it's the right shirt.
I think it's your
All right. Hello, everybody. I'm really happy to be here with so many well-known colleagues. And good afternoon and good day to all the participants. I was supposed to talk about the use of organic methods to fight varroa mites, and this is what I'm going to do. But I'm not going into details of how we are using each of the methods, because I don't think that this is the reason why we want to talk in this webinar about the organic methods. So I will try to go on the reasons why we should prefer to use the organic methods. So if you have heard me before talking about the bee health, you will know that this is one of my favorite slides. And because this way I can always show what are the main parameters or variables that they can affect the bee health. They inherent to the bees, like the disease, the parasite, but also the external ones. But take my word as as a personal opinion, not as granted, because maybe you disagree. But I think that pesticides in general are probably the most crucial, and they can affect the bee health in a long term. However, when we are talking about pesticides, it's not only the phytosanitary substances. We can also include the acaricides that we use inside the colony, and that's why I would like to talk about them. And what is the reality today? I choose to put a slide and from a work that was done in 2010, but it showed that somehow after 2005, in several different areas in the United States or Canada, we have elevated losses. And we do know And we are mostly aware, and we try to coordinate efforts also in Europe. Probably you are familiar with this COLOS association. After 2010, that we try to work together to see and mitigate this loss, because they are really increasing. So the reality today is that these honeybee losses, we find them and we see them year after year. And in my opinion, they are really questioning our practice, because we do not, till now, we did not manage to reduce them. It is well known that beekeepers are more and more depending on artificial feeding, consider even climate change. Veterinary, we are depending on veterinary medicines, as well as queens from breeding centers, and maybe just a few. And at the end, we have new technologies that they have been developed. But if we are talking about diseases or the parasites, then varroa is still #1 pest, and we are not able to combat. In this big, huge colossal, in fact, organization, there is a task force called a varroa task force. And what you can see here is this adoption of the integrated varroa management scheme. And at the base, where we think that this is the most important, is the breeding for resistance. Then you move up to the pyramid in the physical or mechanical ways of combat varroa, then go to biological, biorational chemicals, but they are not so different from biological ones, but still they can be used, some of the chemicals that we know. And then you go to the conventional acaricide, that you see that they are part of the most narrow part of the spot, the top of the pyramid. So we do believe that the conventional acaricide used in honeybee colonies, they should be limited. Now, one of these initiatives and activities that we have in COLOS is also the CSI varroa. And why I mention it? Because in order to fight your enemy, you need to know your enemy. And not only to know its biology or development during the year, but also to know when there is a high increase, where it's low increase, what is happening after the treatment, and how this differs between the different countries and environmental conditions. So, in fact, you know the effectiveness of the treatment, as well as when it is the right time, and where are the thresholds that you should not exceed, or your disease prevalence should not exceed, in order not to have economic impact on your colonies. And this is now going into the end of the activity, but with a lot of results from many different countries. And there we hope that we might also have maybe a comparison between conventional or organic methods. Now, before I go into the effects of the conventional methods treating varroa, I step on one of the latest publications, but it's a comparison between the chemical-free, conventional, and organic apiaries. That you can see how big the varroa is, what is the prevalence of varroa in conventional and non-star. Yes, you do see my mouse. The conventional, the chemical-free, so there is no treatment. The conventional is the blue, and the organic treatment is the green. But of course, we expect to have more varroa in no treatment treated colonies. But then also you have nosema on this graph in the middle, and the deformed wing virus. And it seems that it's not a big difference, or it's no statistical difference, in fact, between the conventional and the organic treatment. There is, of course, some difference with the not treated colonies. And the same also applies for the survival of the colonies or the honey production. Still, this it is one of the few studies that shows comparison between this type of management schemes, but practice shows differently. Practice shows that organic treated apiaries have less losses, and they might have sometimes even higher honey yield. But of course, there are just few studies. We should continue on this. But in this study, there is the colleagues did not take into account the benefit and cost balance for economics or the cost of chemicals, for example, labor. But this is really very interesting, and we should look into this even more. Then if we want to see some of the effects, and we're talking about resistance mainly, because all the chemicals that we use in the colony, they do create some kind of resistance, and this is part of the antimicrobial resistance that we are talking about today. And on your left, you can see from a study published in 2020, on your left, you can see the resistance, the result with the use of coumaphos, and then on the right, the results with tocrubalinate. Both of these substances, they know that they have created a resistance, and you can see that there are still some dead colonies. Also, if they are treated with coumaphos, also, and even more if they're treated with tocrubalinate. That means that they are treated, but at the end, they do die. So why really they do die? It's the question, and why we should reach that point. Pyrethroid resistance is something that it has been questioned and researched a lot. And you can see that immediately when this correlation between the years used that we use pyrethroids, then immediately the frequency of the mutant appearance in the mite is increasing. And in the varroa task force, we started also showing what is happening on our own apiaries with at least 3 of the chemicals, amitraz, flumethrin, and coumaphos. And I just want to point out that this is what you see on your left. This is from our own apiaries in my own institute, and we never use flumethrin. And we still have resistance of varroa and flumethrin. We don't really know how it got there, so this is really worrying to know. I put up a few of the results that show the combined effects of miticides on the mating, for example, health of the honeybees of the queens, on the foraging time, on the first onset of flight of the workers, that you have really reduced ability on the foraging. Also, we think that we treat varroa with the synthetic acaricide, but at the end, we cannot, of course, treat the viruses. And in fact, we have higher susceptibility to viruses. We also have other kind of sublethal effects that we need to tackle more and make sure that they don't really happen to our colonies. I don't want to go into details, but they show immediately the difference and the reason why we should avoid using the synthetic acaricides and using the organic substances that they are available. And this is another example for Apivar and Thimovar. Now, if you want to look into physiology of the bees, one example is, and this is one of the enzymes that we use, the glutathionase transferase. This is one of our own experiments that shows the profile of the enzymes when how it should be, and then after we use amitraz, perazine, thymol, even the bivalol, you know, this that is contain flumethrin, and of course oxalic acid. All of them, they do have some kind of effect on the profile of this enzyme. And this is a very important enzyme because it's responsible and shows detoxification ability of the bees. Oxalic acid has the less effect on this. So we should be really very careful on what we are using inside our colony. And another recent example that has been published yet is the persistence of these chemicals. For example, on your top left, you see the effect of oxalic acid after 28 days or after 58 days. I mean, similar amounts from the control, day 28, day 58 after the use. And on your upper right corner, then this is the formic acid that shows that it's increasing a little bit and then it goes down because there are natural substances that they are there anyway, and we know that because bees are using it and they found it in the nature, but with the use as veterinary medicines, then even if formic acid can increase a little bit, then it goes down very quickly. Still, at the bottom of this graph, you see the three metabolites of the amitraz. The DMPF, the DMF, and the DMA. I don't really know what's the actual names, but you can see that although in the control there is nothing, sometimes there is some contamination, but then immediately with the use they are increasing, and then they are adding up. Instead of disappearing, they are adding up, and this is very worrying. So the last one. So here are all these methods, tools that we have for using organic substances in many different combinations, in many different ways that we can use them in the colonies. And this is, how to say, this is the proof that we are not without weapons against the enemy. We do have efficient ways to treat against varroa, and sometimes even with a combination, it could be even better, together also with what we call the biotechnical methods. And we should think about more of how to use them and how we can make the life of a beekeeper easier, also spending less because they cost less than the chemicals that the step can. I would like to leave you there. Just stating that the bee products are not only important for the bees, but they are also important for the humans because we use them as food, as cosmetics, as medicines. So whatever we put into the colony to treat the varroa, if it's not really bee-friendly and organic and, I don't know, human healthy, at the end it comes into our product. Thank you for your invitation and for your attention.
Thank you, Fani. I think your presentation was really enlightening and instructive. We will now move on to the fourth presentation of the day, which will be provided by Dr. Beatrice Nganso from the International Center of Insect Physiology and Ecology. Dr. Beatrice Nganso is a research scientist in commercial insects under the environmental health team, and she holds a PhD in entomology from the University of Pretoria, South Africa. She is a member of COLOS, the Honeybee Research Association, in the African section of the International Union for the Study of Social Insects, an African association in insect science. So please, Dr. Beatrice, the floor is yours.
Hello to everyone. I'm really happy to be among you. And thank you for the invitation to share the African experience on biosecurity in beekeeping. So good afternoon to everyone. So my talk would basically focus on the identification and sustainable management on some honeybee diseases and pests in Africa. So to begin with, I would like to say that, okay, 1 minute. I think I need to put it in this presentation mode. Sorry about this. Okay, to begin with, I will not dwell a lot on honeybees because we know of their importance as pollinators of many of our food crops and also wild plants, but also the role they play in improving the livelihood of so many communities across the globe. So basically here, I'm just showing the annual value of pollination services that they provide in Kenya, which is about 186 million USD. And in Ethiopia, it's about 815 million USD. But besides the honeybee, which is the well-known pollinator, we also have stingless bee species that are really limited to tropical areas. And in Africa, we have, like in Kenya, for instance, we have so far shown that or recorded 12 stingless bee species. And studies we have conducted at ICIPE, we actually show that there are some stingless bee species that are key or really efficient in crop pollination. Like the Meliponula bucande, we found that it is a really good, efficient more than the honeybee to cucumber, for instance. And for the yellow bell pepper plant, we found that Hypotrigona griboide is also playing a major role in the pollination of this crop. But we also have the capital bees in Kenya. You know, we don't have a bumblebee that can provide boost pollination for some crops such as the tomatoes. So in Africa, we have carpenter bees who are playing that role. And at ICIPE, we have been able to domesticate them and use them in greenhouses to pollinate the tomatoes. And from preliminary studies, we found that they are really efficient in doing that. But then focusing now on the honeybee, we know that they are declining all over the world. And this decline has been attributed to so many factors that sometimes interact together. But what is, so looking now at what is really happening in Africa, what do we know? So a recent study ICIPE contributed, whereby we were looking at these different factors across the globe in different continents. So we clearly see that in Africa, what are the key factors that contribute to, that could threaten the biosecurity of beekeeping? We found these studies show that the land use change, pesticide use, and climate change are playing a major role. But unfortunately, most of these studies, from what we can see here, they are either not well established or inconclusive, which means there's still a lot of work that needs to be done. And then regarding also the pest and pathogen, we see that compared to Europe, where it is well established, and in Latin America as well, in Africa, it's really minor. It doesn't, we have not got enough data to say that pests and pathogen are playing a major role in this. But then from what we are observing currently in the field, we really are observing that they could also play a major role in bee decline from the various beekeepers that we have been working with. So looking at the pest and diseases that affect the bees, okay, studies done by Christian Perk in Pretoria and also ICIPE they have been able to record different pests associated with beehive. You have the famous varroa mite, which is a global pest. You have the trachea mite. You have Tropilelaps, which was recorded only in Kenya so far. You also have the small hive beetle, the large hive beetle, the wax moth, and bee louse. And so in the course of my presentation, I will focus more on the species which I've highlighted, because so far we have some of them are of global importance, but also some within the African continent are playing a major role in colony losses. We also have different types of pathogens that are associated with the hive in Africa. And what we have seen so far is that also data on all of these viruses or bacteria or fungi that are associated with beehive in Africa, we don't have accurate data to really tell how do they affect the fitness of the honeybees. Data in this perspective are really lacking. And so here I highlighted the deformed wing. I underlined the deformed wing virus because this is a key virus that interacts closely with varroa to limit colony productivity and also health. So I'm going to discuss all of that and show what we have done so far in Kenya, focusing mostly on Kenya in tackling these different pests and diseases. So like we all know, varroa is of major concern also to us in Africa, because so far the strain reported on the continent, as you can see on this map, is the most virulent varroa haplotype called the Korean haplotype. And this pest is really devastating because it deprived the bees, the honeybees, of its essential nutrient. But at the same time, it vectors, since varroa has arrived in Apis mellifera colonies, we see that there has been a spike in the level of some viruses, specifically the deformed wing viruses, mainly because the immune system of the bee has been compromised. And so why did we do a lot of work regarding the varroa mite? Because since this mite, data has really shown that he's contributing majorly, is one of the major contributors to bee decline in North America, Europe, and even in the Middle East. But in Africa, there's also a concern that we should take preventive measures to really tackle the varroa problem. So what we have done, and also based on the fact that we know that one of the key management options, as Fani said, in tackling varroa is breeding, selecting some traits such as hygienic behavior to improve colony ability to resist the mite. We have tried to understand what are the level of expression of some of these behavioral traits in African bees compared to European bees. So what that I've done, doing my PhD at ICIPE, that was in 2015, I simply compared grooming behavior against varroa between Apis mellifera scutellata in Kenya and Apis mellifera hybrid of European origin in Florida, that is in the USA. So I basically look at the grooming intensity within the hive, but also looking at the mite infestation. So our data clearly show that the infestation level in African bee was quite low, significantly lower when compared to those in European colonies. And also, what was really striking is that the level, even though we found these differences, the level of mite damage was similar between both populations. But then when we took the ratio of total natural mite fall to the mite infestation on adult bees, we found that it was significantly higher in African bees than European bees. So this study clearly showed that African bees, even though they have a very low mite infestation, they have that tendency of cleaning the mite off their colony better than the European honeybee. That was the conclusion from this study that we published. So next, we also currently, I have a PhD student who is looking at, is there any impact of landscape or climate on the ability of bees to groom the mite? Because we know that, okay, land use change is playing a major role in, it might affect the health of African bees, as the study I've pointed out earlier. At the same time, climate change also has been highlighted as one of the key factors. So now we wanted to find out whether these key factors are playing a role in the ability of bees to interact with the mite. So we quickly classified, this study was conducted in the Amhara region, which is one of the key honey producing region in Ethiopia. And we clearly see from this study that when we compare the grooming ability of the honeybees, it differs among the landscape type, that is lowland, midland, and highland in terms of the vegetation cover. We clearly see that the lowland is quite distinct. The grooming behavior of bees against varroa in the lowland is quite distinct from the midland, but not so from the highland. And this could be due to, it could be due to the genetic factors, which we are trying now to analyze, to look at the different bee species that are occurring in these different places, because there has been a lot of controversy regarding the subspecies of honeybee occurring in Ethiopia. So this could have a genetic effect. It could also have an environmental, like the landscape, the type of flowers, and that are available in the different landscape, whether they are nectar rich or pollen rich floral resources. Those are also being analyzed at the moment. And also from when we look at we look at the interaction between the site and the season, we also found that site has an impact on grooming, that is the landscape type. Season also have an impact on the on this grooming behavior of honeybees towards the mite, but also their interaction is also affecting. And from this study, we clearly see that landscape and climate change is something that we should not ignore when we are looking at bee health in Africa. So at the same time,
sorry, Dr. Nganso, I would kindly ask to move towards the end of your presentation as we thank you.
Okay, that's fine. Okay, then we also look at the hygienic behavior, and we found that hygienic behavior between African honeybees and European honeybees are almost the same. The expression are the same. And most interestingly was the fact that the reproduction of varroa within the honeybee colonies in Africa was quite low. It was lower than what has been reported for European honeybees, as you can see on this graph. The fecundity and the number of mated daughter was very low. And this data aligns with what has been reported in Pretoria. And further to this study, we have other students that look at varroa-specific hygiene behavior, showing clearly that the expression level is quite is high in African bees, Apis mellifera scutellata, compared to levels reported in Europe. And then recently, a study by De Souza in South Africa clearly showed that because of these different, because the expression of all of this behavior is quite higher in African colonies, it also helps in controlling the deformed wing virus load. So in conclusion, we are unanimously saying that is researchers at ICIPE and Pretoria who have done this work so far, and Ethiopia came to the conclusion that beekeepers in Africa should not use any control measures against varroa because the bees have this innate ability to control the mite and its associated viruses. But at the same time, we have some occasional pests that occurs in Europe that are occasional. But in Africa, they are causing a serious damage, as you can see on this graph, damage which can go up to 40%, like the wax moth. And so one way of controlling this, and this happened mainly because the beekeepers, because the bees are so aggressive, they just set up the hive, leave the hive there to strive on their own, and just come in when they want to harvest their honey. So by that time, the damage will have escalated. So what we do, we mostly educate them through training. We provide practical training, but also field training, field training, how and educate them how they can maintain their colonies to improve or to fight against these occasional pests. So mainly we advise them to maintain a healthy and strong colony, or don't leave empty wax comb hanging around, because this serves as a source of food and reproductive site. And so these are all the advice that we provide to them. Another key pest that we recently found is the large hive beetle. This is a pest that is confined only in Africa. And recently in one of our study area, we are recording very high amount of the large hive beetle causing up to 50% of colony losses. As you can see, their numbers, we record more than 600 large hive beetle in just a single hive. And currently, I have a student, because this is a pest that is coming up now as a serious pest to colonies. And so there is need to carry out massive research. So far, we educate the farmers also to close the hive, to maintain, to reduce hive entrance, maintain strong colonies. But at the same time, beside all this advice, we currently have a student who is quantifying the economic impact of this pest, and also assessing the influence of hive attribute, whether Langstroth, top bar hive, or Kenya or lock hive, the type and the landscape on the distribution and the occurrence of this large hive beetle in the field. And also we want to determine whether they have alternative hosts, because we notice that they only occur during a specific time of the year. That is when the brood amount within the hive is picking up. So we want to understand whether they have an alternative host that we can use to develop traps to reduce their number in the field. And now, coupled with the fact that we really know very little about what are the key factors driving colony losses in Africa, I recently initiated an annual survey of honeybee colony losses in Africa in partnership with the co-chair of COLOS, that is a beekeeping group, and also the University of Pretoria. And so our preliminary study in Cameroon, that is in Central Africa, showed that for natural disaster contribute massively to these losses, mainly bushfires, and then also thieves, followed by absconding, and then issue related to the queen. And so we are awaiting data from the other 8 participatory countries who are currently collecting data. So at the end of the day, we'll be able to tell what are the key factors contributing in different countries to colony losses, and then design jointly in partnership with COLOS management option that we can use against the threat. So at this point, I would like to say thank you to all our donors who are supporting our research in beekeeping at ICIPE. And yes, that is it. Thank you for listening.
Thank you very much for your constructive presentation, Dr. Nganso. I will now ask Dr. Giovanni Formato to start the last presentation of the IB symposium. I would like to first introduce Dr. Formato, who is a veterinarian expert in bee diseases and management. Since 1998, he works at the Experimental Zooprofilattico Institute of Lazio, Toscana. Dr. Formato is in charge of the Laboratory of Agriculture of the Zooprofilattico Institute, where he coordinates the FAO Reference Center for Animal Health and Food Security, and the WOAH Collaborating Center for Good Beekeeping Management Practices and Biosecurity Measures in the agriculture sector. Please, Dr. Formato, I leave the floor to you.
Thank you very much. First of all, thank you for inviting me to present the B-THENET project and how it impacts on sustainable beekeeping. Sorry, I try again to share the screen because it's not doing that. Okay. Thank you very much. So, what is B-THENET? B-THENET is a Horizon Europe project, and it is based on a multi-actor approach. what it means? It means that it wants to allow beekeepers, researchers, advisors, policymakers, industry, consumers to put all together around the table and possibly even around an apiary if they are beekeepers and advisors, and discuss together to solve the main aspects of European beekeeping. So through this multi-actor approach, the goal is to reach a profitable and sustainable beekeeping. So how B-THENET impact with sustainability? It's very, very easy to say that it impacts 100% because the goal of this project is to go toward sustainable beekeeping in Europe. What are the goals of this project? Mainly is to categorize the practices of European beekeepers and trying to tailor those practices at national level. This means trying to adapt practices, beekeeping practices at a level of each nation, considering the typical environment, typical bees, typical beekeeping equipment that is there present, and develop practices according to the real situation that is present there for beekeeping. In the same time, it wants to modernize the European beekeeping sector through innovation that is ready to be put into practice. So this project is not focused on making research, pure research, but it is focused in supporting beekeepers in adopting innovations that is ready to be put into practice to foster the results of beekeepers' efforts. Mainly, the project works on two different planes. One is at informatic level, using a platform. Through the platform, beekeepers can interact together with advisors, researchers, and so on. And in the same time, at level of each country that is participating to the project, they will be able to find a place where to meet other beekeepers, to discuss with researchers and so on, and even to test the different practices. Now, let's go to see who are the main partners of the B-THENET project. As you can see, we have research organizations, like, for example, Dimitra, we have here Ani, and university. There are several universities involved in this project, and there are centers for social sciences and humanities, and we have beekeepers very well represented here with the participation of Apimondia in this project, and we have even other beekeepers representatives like the Slovenian Beekeeper Association, the Danish Beekeeper Association, and della. Moreover, we have communication and dissemination agencies because we want to spread the results that will be obtained by the exchanges between beekeepers and researchers in describing practices properly, even providing tools for beekeepers like the videos and short description of the practices through images. And as you can see, even here we have again the possibility of interaction between beekeepers and researchers, because this is the real aim of this project, the interaction in a multi-actor approach. If we go ahead, we have in the advisory board even the presence of two important organizations that are here today involved. That is the World Organization for Animal Health and FAO. Of course, we want the results of this project will be spread beyond the borders of Europe and beyond the species of the bee. Here you can see the places where the national bee-THENET centers, this means the physical centers where beekeepers will be able to interact with researchers and advisors, are located. In total, we have 13 national bee-THENET centers. So beekeepers will be able to discuss in their native language, in their local national language, together with other beekeepers and researchers. So we don't have the obstacle of the language for beekeepers. Moreover, in the same time, we will have 3 international bee-THENET centers where it will be possible for beekeepers to compare different practices that are adopted in different countries, and even to speculate and possibly even to thinking changing in better. So for the International bee-THENET Center, as you can see, beekeepers are represented by Apimondia, and Apimondia is taking care of these international bee-THENET centers. Concerning the International bee-THENET Center for Advisor, here we have different realities. Advisors in some part of Europe are represented by veterinarians. In other parts, they are represented by beekeeping technicians. So it will be important in this stage to trying to differentiate and to harmonize and to integrate these 2 different possibilities. And the goal is trying even to harmonize their activity all over Europe. So far, we have a very different situation concerning the interaction of advisors with beekeepers. Finally, we have the International bee-THENET centers for other stakeholders. This means all figures that are different from beekeepers and advisors. As this International bee-THENET center will be taken care by BeLife in Junxia. What we are doing, the project started on September 2022. So we started to identify practices to describe and to discuss with beekeepers and researchers in Europe. So the first step was with a bottom-up approach, asking European beekeepers which were practices they considered important to be described, important to be clarified. So we run EU survey. We get results from 2,094 beekeepers from 22 member states. And as you can see, concerning the good beekeeping practices, the practices that will be described and discussed at level of the national and international beekeeping bee-THENET centers will be 13 practices concerning the apiary setup and management. Concerning, on the other side, the biosecurity measures, so here we are discussing about the diseases. For varroa, beekeepers in Europe decided to give priority to 9 practices to guarantee the varroa control, especially with organic compounds. I thank you very much for your kind attention.
Thank you very much, Dr. Formato, for the very constructive presentation. Before we move to the question and answer session, I would like to thank all the speakers for their inputs and for their inspiring efforts and work towards the achievement of a more sustainable management of the honeybee. So I ask our kind audience to leave their questions in the question and answers box. And until more questions arrive, I would like to propose a question to Dr. Jieun Kim and receive the question concerning the progressive management pathway. So how can the progressive management pathway be applied in different national contexts?
Yeah, so to apply the PMP approach, there's no requirement for the countries. It's very simple because we prepared all the steps. There were 27 countries on the 5 areas. It's very easy that the country can directly contact. And then when we organize this meeting, we always have this round table to open the discussion among the stakeholders. So FAO can also provide a moderator to guide the discussion, but the assessment is basically by the national beekeeping stakeholders and other One Health stakeholders discuss this topic and then which level they currently are at, and the agree finally for which level, and then discuss how to move forward to the next step in short or medium term. So this is how it works. So there's no requirement because at any stage, country can apply this approach. So this is a very strong benefit for control.
Thank you very much. Thank you very much, Dr. Jieun Kim. I would like now to kindly ask Dr. Alippi for a question that we received in the chat from Rafael and Royal. Pages look as promising. Sorry. Where is the? Sorry. I apologize about the technical difficulties. We carry on with the question now. So pages look like a promising tool. Where is the complicated part of the technology in order to have them operational? Is it a technical issue or more a legal, commercial issue? Or do we still lack sufficient knowledge in order to fully trust it?
No, I think it's particularly a commercial issue because we need to interest a laboratory who would like to commercialize it, and also maybe the form of application for the colonies. For instance, there are many, at least in Argentina, there are 2 or 3 different preparations with bacteriophages for humans. I don't remember the lab, maybe Pfizer, but I don't remember the trademark. Anyway, they used to treat dysbiosis in the human labs, controlling the bad bacteria like E. coli, and leaving other bacteria, other benefit bacteria unharmed. So, if it is possible to prepare a formulation for humans, why not for bees? I think it's a problem of commercialization and also maybe formulation to keep the phages safety in the colony, because it's not the same, the colony and the human guts. But I think it's, that's the problem, the main problem, not the technical.
Thank you. Thank you very much, Dr. Alippi. It was a very constructive answer. I would like now to kindly ask you a question to Dr. Formato about B-THENET methodology. Could this methodology be applied to different species of managed bees?
Yes, so far we are approaching only Apimondia, but it should be very nice trying to adopt the same methodology even to other bees that are around the world. Of course, this is our first year, we are doing that, but we are already starting to collect some feedbacks from keepers and from the activities we're doing. It should be very nice to transfer this knowledge to other countries or to other beekeeping sectors that could be interested in adopting this approach. Of course, the things will be very different from one species to the other, but it is normal. Thank you.
Thank you very much, Dr. Formato. I would now like to ask a question to Dr. Fani Hatijna. It is accepted that the organic acid and organic methods are safer for the bees. However, how are they as effective as the synthetic chemicals?
I'm not sure I understood exactly.
So,
The organic acids are
Yes.
affected.
Yes.
So in comparison with the synthetic acid.
exactly.
All right, okay. Well, from my personal experience, I think that they are very effective. They can be very effective. Of course, maybe they are more related to the environmental condition or weather conditions. And maybe it's not, the effectiveness could not be the same during the year around. But it can be very effective, especially when there is no brood around. And the most important is that because they don't leave residues, because they do minimum maybe because everything has an effect on this, then you can apply them again. So they can be really very effective and they cost less, which I think is very important as well for the beekeeper.
Thank you. Thank you very much for your comprehensive answer. I have another question in the Q&A box. So, I'm sorry. Thank you. The One Health concept was mentioned several times during this seminar. Mobilizing the links between bee health, human health, and environmental health be an argument for beekeepers to change their practices. Do you mobilize it as an argument? Thank you very much for your answer. So, yes, so if mobilizing the links between bee health, human health, environmental health, can this be an argument for beekeepers to change their practices?
Maybe.
Please, I think this was from all the experts.
Well, this is something that we discussed between the scientific community a lot. I remember even 1 or 2 years ago. But I was also mentioning this morning in a discussion with them that we prepared a short video in Apimondia, believing that the health of the environment and the quality of the environment is important for the plants, for the bees. So you have better environmental conditions, you have healthy bees, and at the end, when you have healthy bees and better quality of the environment, you use less chemicals in general, but at the end, they all come to your plate. So the human health is influenced, not only because we have airborne particles and things like that, but because you eat everything that you are using in the crops. So everything, it is connected, and we should be really very much aware of this and work towards the One Health approach. This needs to be, how to say, not just communicated to the beekeepers. This needs to be educated, through the training, because otherwise they will never use it because they have to see it. And I think that they start seeing it, consumers as well, together with the beekeepers. That's how, for example, the demand for the organic products is higher. And that's why now we have higher number of people, farmers plus beekeepers, that they are practicing organic agriculture in general. So I think, it can be done and it's important.
Thank you, Fani. Thank you. I see Dr. Formato would like to answer.
Yes, I would like to integrate this. I think beekeepers must be aware, for example, even in reducing the antimicrobials they use for the problems of the residues, antimicrobial resistance, things that were already very in deep underlined. And I think that not only beekeepers, but even people in general should understand the impact that the not proper use of pesticides, for example, may impact on the bees. But at the end, we have another impact that is even on human health. And so, yes, I think this is a general concept that is important for everybody to be understood. That beekeepers are the first person, but even other people.
Thank you, Dr. Formato, for integrating these slides. I think we get much better understanding of the topic. And I am just checking now the question and answers box to see if there are any more questions, which I don't see. Perhaps I will wait.
Okay. Please, oh, sorry, yes. Is Dr. Nganso, if you would like to integrate.
Yeah, it's Beatrice. Yeah, I just want to ask a general question regarding since we are talking about the biosecurity of beekeeping. And there's been I've been wondering regarding this is a question that has nothing to do with the presentations. It's just a question I will throw to members of Apimondia and FAO just to give me their thought on it. We have now a lot of invasive species, which are, some of them are spreading across Africa, like the Ipomia. And we see that beekeepers in certain areas in Kenya, they are really saying, oh, the bees love the flowers, they love the plants, but we don't really know what is the fitness effect of them feeding on these plants. So I don't know, in your perspective, what do you think, how do you think we can manage this invasive plants, because invasive plant, because first they are not good for the native plant species, but then the bees love them, okay? So how do you think we can approach their management? Yeah.
So, Beatrice, thank you for that question. I'll speak from Apimondia's perspective. We do realize that beekeepers around the globe, there's many examples of invasive plant species that is beneficial for bees, but that doesn't mean it's right to promote that species. Melaleuca in the U.S. is one. And you mentioned that was Japanese knotweed that spreads around the globe. So I think, though, there are examples where local governments or regional governments have started eradication programs using, actually with the use of biocontrol, like a weed or something to fight the plant, that rather than a herbicide, where they can try to reduce or eliminate. You'll almost never totally eliminate invasive plant species to reduce it. And it's a balance. We just have to educate the beekeepers that it would be better to find local good sources of native plants and flowers to utilize, and rather than some of these invasive species. Because you're right, they choke out other native plants. So it's not only a question of education, but just that we have to convince the beekeeper that it's not the best way.
Okay.
Thank you very much. I see another question in the box where it is asked if it's possible to share the presentation. And yes, after the end of the webinar, we will share the presentations. Yes. Don't see any more questions. So perhaps I will wait another few minutes, few seconds, and then we can raise the symposium. So I kindly ask our audience if they have any more questions to share them with us now. Oh. Thank you. Well, I would like in the meantime to thank our audience for their thought-provoking questions, and I will very kindly thank our speakers for their contributions. Again, it's very inspiring to see joint efforts towards the achievement of sustainable management of the honeybee. And I would like to give the floor to Dr. Formato now, who will bring the closing remarks to the Biosecurity Symposium. Thank you, please, Dr. Formato.
Thank you very much. It's a really an honor. So, dear participants, let me say that today we experimented once again the presence, the active contribution, and above all the interest of the 4 different organizations that promoted today's meeting in biosecurity and beekeeping. It seems then a good moment to start exploring the possibility to establish an international working group that could provide recommendations on how to reach at best sustainable beekeeping, going beyond the frontiers of countries and of the bee species. How to do this? Is it difficult? Yes, it may seem difficult, but it is indeed possible if we know the pathway to follow. And we already have the pathway. Yes, it's represented by the FAO PMP document that Dr. Jieun just presented in the first presentation of this webinar. But let's discuss this further in the next webinar that could take place, for example, during the Apimondia Congress 2023 in Chile, of course, if the president agrees.
I think he agrees.
We'll find it.
Thank you. And so I thank once again the four organizations that made this event possible, and see you soon on the screen of Biosecurity in Beekeeping. Goodbye.